All right, welcome everybody. It's Monday, April 27th, 1 p.m. in the afternoon, and it's D period Algebra 1. Hope everybody's doing okay considering the less than desirable circumstances we're all operating under. I've got a couple announcements. Please put your name on problem sets and classwork homework, because when I pull them down from Dropbox and print them out in mass, and if there's no name on it, I got it, and I don't recognize a distinct handwriting, which most of you don't have. A couple people do, but not many. I got to go back in and go on a scavenger hunt to try to match a problem set or quiz with a person. So please put your name on, and that would help me out immensely. A couple things I downloaded some of the quizzes over the weekend, because the 5-2 quiz, which was actually due last Friday, but I don't see any quiz in there from Mr. Abelhausen, Mr. Carmen, Mr. Garcia, Mr. Melendez, Mr. Myers. Okay, I don't see any quizzes in there from you, so if you want to turn them in today, a late score is better than a no score on a quiz. And then after today, I'm just going to give you a 0 and move on, because I've got 6 classes now and 80-some students, and I can't keep going back trying to find out who's going to finally jump in and do work. Reference the names on quizzes. I did catch these as I was printing them. Mr. Bigelow, no name. Mr. Cash, no name was on yours. Mr. Landis, no name was on yours. And Mr. Walker, you sent me 2-page ones of your quiz, 2-page ones, but no page 2. So if you can send me page 2.
Will it be late though?
Do it, no, do it just, hey, I've had my issues with technology here, so just send it to me via email, not in Dropbox, okay?
Okay.
Wait, sir, do we have to have our names on the quizzes and stuff from now on?
Yeah, because I can't, when Dropbox isn't, user-friendly extensively, and when I print them out in mass and there's no name on it, then I got to go back and pull each one up individually till I find one that looks like this one with no name on it.
Mr. Gaffney,
Somewhere.
can I show you my problem set now?
Yeah, let me get my paperwork. All right. Turn
Oh
it,
yeah, me too.
turn it over so I can mark it off.
Well, no, I can't do that really.
And I turned all my other work in the Dropbox, and because I emailed it, but the email didn't go through over the weekend, I just put it in the Dropbox.
Yeah, let's see. Yeah, I did get I got your quiz, Mr. Cornett.
Hey, Mr. Gaffney, I don't know like which page you have, so I'm gonna just send you both pages again.
Yeah.
Is that cool?
Yeah, what I got was 2 of the first page. I got the front page, the low numbers like 1 through 7 or 1 through 8 or 9, but I didn't get the back page.
All right, so I have this one right here, but it's 2-sided, so I'll just send it to you again.
Okay. Yeah, do it via email, not via Dropbox. Otherwise,
So,
I got to.
You said like it won't be late, right?
Because I can sympathize with you. I've had my technology.
Thank you.
And, we're all getting used to the new system. You sent it, it just, inadvertently you got 2 side ones.
All right.
All right.
Oh, and I gotta leave your class really because I gotta work in a few minutes. So
Okay.
maybe I'll get like a few points just coming here.
All right.
But if not, that's cool too.
Let me know.
All right.
There is a problem set number 2 for 6.64 that's already in Blackboard. You don't need to put it in Dropbox. You just need to complete it, and we're going to go over it first thing on Wednesday.
All right, yes, sir.
All right.
I'll be here for a few more minutes. Like 10 minutes.
All right. So let me tell you the plan of attack here for today.
Wait, Coach Gaffney, I had a question.
Yes, sir.
Did you say I didn't have my quiz?
I don't have a quiz for you unless you put it in the last 90 minutes. When I checked about an hour ago, was playing catch up. There's no quiz.
It was the first quiz we took, right?
It's the 5-2 quiz from last Wednesday that was due on Friday.
Oh, okay.
But I'm still missing the 4-5 quiz from you. I think I only got side 2, and I never got side 1. That's why I think you're still showing a 0 for the 4-5 quiz. So if you've got side 1 there to me, side 1, email me that so I can get because so I can grade the whole quiz and not just give you credit for half a quiz.
Okay. And is there any way you can like send me the quiz that I missed, the last one? I don't think I ever got that.
It's go into Blackbot for last Wednesday, the 20, I think it was the 3rd, maybe.
Okay.
Mr. Gaffney?
Yeah.
Is the worksheet we're gonna do in class up on Blackboard yet?
Yes. We're going to do problem set 2, section 6.4. We're going to talk about problem set 1 before we jump into 2 because it's similar. It's similar work, but one we got to do manually and one we got to do electronically. And I'll distinguish between the two of those once we get started on the lesson. Any other questions or housekeeping chores we need to clean up before we?
Oh, so we're just going over our homework in class today?
We're going to go over the problem set from Wednesday, okay? And then I'm going to get you started on the problem set for today and just have it done by this next Wednesday. You don't need to put it in Dropbox, okay? You don't need to put it in Dropbox.
Just have it ready for class.
Yes.
All right.
Because this is kind of a unique thing. We're going to do it all on TIs, on calculators. So make sure Abelhausen, Harmon, Garcia, Melendez, Myers, that you get me your quiz today. All right. It was due last Friday.
Sir, I sent the quiz to your email like the day it was due. I emailed you. I said I hope this is okay because my Blackbot isn't working to turn stuff in.
All right. Let me make a note here to see if I can find it in emails. If it's not, I may send you an email.
Okay, it was I sent it to you through my phone because I took a picture of it on my phone and sent it to you.
Okay. All right.
So it's under a different email.
It's not from Melendez. It's from somebody.
No, it still says Logan Melendez, but it's like at iCloud, not at Gmail. So.
Ooh, because I've had some issues with iCloud stuff from a couple other students. Because I'm missing a whole bunch of stuff from you, and I don't know if you're sending it that way, and that's why I don't have any grades for you.
Yeah, I am sending it that way.
Do you have a Gmail account or a Yahoo account? Because
I do have a Gmail account. It's on my computer. It's to my computer though.
to your computer.
And I can't take any pictures off of there, so I didn't know.
Well, can you take it off your phone, send it to your computer, then send it to me via email, other than iCloud?
Okay.
Because iCloud, that might be the factor. Because I've had a couple issues with. I don't want to mention names, but someone in another class. I'm not sure what iCloud is doing to it, or maybe I don't have the compatible iCloud receivers here that I'm getting it.
Wait, actually, now that I check my sent, I did send the pictures and sent it to you I sent it from my phone and did send it to you through the Gmail account that I usually email you by. The
All
quiz,
right.
but the other things I have been sending it by iCloud.
Okay. All right. I'll do a search on my email to see if I can see what I can retrieve or find.
Yes, sir. Thank you.
And I may send you an email if I'm still having difficulties, accessing what you've sent me.
Yes, sir. Thank you.
All right.
Yes, sir.
All right. Any other housekeeping chores? All right. Give me a second here. I got to pull something up. Let's see here. Let me share screen. 6.4. Okay. So does everybody have 6.4 problem set 1 in front of them? Oops. Okay. If not, grab that. Let me see if I can share my screen with you. Okay. Let me get rid of some of this garbage on here. Okay, so we started talking about nth roots which could be anything from squared roots that you've got fairly good expertise in to cube roots, which you got some expertise in. And then that was on this problem set. And then the one that we're going to do today, we're going to get into 5th, 6th, 7th, 8th roots, which those, they're not going to have any variables under the radical. And those we're going to do strictly with a TI. So you're going to need a, you know, if you don't have one, need to have a TI or a calculator that can do roots other than squares and cubes, because we're going to get into 4th, 5th, 6th, 7th, and 8th roots. Not that that's any surprise as far as the TI, because you're supposed to have one all year long, but I haven't strictly enforced it. But you'll need a pretty decent calculator to do some of the roots that we're going to do after this problem set. So if you've got yours in front of you, we're just going to go through this orally, and then if I need to write them out, I will write them out. And some of these we did in class yesterday, but we'll just start from number 1 and go down the line. And just let me know if you've got any questions. Number 1 was 9. Number 2 was -7, and it is doable because we have a negative under the radical, which is fine when I've got an odd root. Perfectly fine. Number 3, the 144 comes out as 12. And one way to look at this, we've done similarly. We're going to take the square root of p to the 6th. Well, what's the square root of p to the 6th is p to the 3rd. Okay. Pardon my handwriting. All right. And if you remember, if there's nothing written here in this little corner of the radical, it's always the square root. And remember when, if we had like, let's just use p also. If we had like p squared, let's use something different. If we had p cubed and then the whole thing to the 4th power, to solve that, remember we multiplied. So that actually equaled, I'm not going to write it, but that equaled p to the 12th. All right, so we multiplied. So kind of the converse of this is we're going to divide the 6 by 2. All right, so this is kind of the this is the exponential way of solving it. Here's the radical slant root way. So this was multiplying, okay, and then this one here to solve it, we're going to divide. Does that make sense? All right, if I don't hit, just break in and I'll answer this. Don't get hung up on this plus the minus. It's outside the radical. The radical has nothing to do with it. So the 4 comes out as 2, and the a comes out as a to the 5th. All right, so now we got to the 5th power. So I'll do the easy part first. So that the p comes out as p squared, because that's the same as p squared to the 5th power, all right? And then we got to take the 5th root of 243. Well, we know it's going to be an odd number, all right? So if you just take the 5th root of 243 and put that part into your calculator by itself, not with the variable, you'll come out with 3. Stop me if you got a question. The negative outside the radical doesn't do anything. 6 divided by 3 is 2, so we got negative m squared. The 9 divided by 3 is 3. Pretty straightforward. Any questions on those? All right, fair enough. This is pretty straightforward. And like I said, some are doing it, it's kind of mental math, some are doing it with calculators.
What was number 6 again, sir?
Number 6 was negative m squared into the 3rd.
Sir, I have a question.
Go ahead.
How do we do it on the calculator?
The variables with the exponents, I'm almost off the top of my head, I can't tell you. I'll play around on YouTube and see what I can find.
Okay.
It's almost, because the number, we're just talking about square cube roots and 10th and 4th and 6th and 8th powers. It's almost better just to do it either pencil to paper or mental math.
Okay.
Well, I'll make a note here to see if I can find a way to do it. It's almost going to calculate, even if it's doable. I don't know that it is. It probably is. It does everything else. it almost seems like it'd be more labor intensive than just kind of do it mentally and or pen to paper.
Yeah.
Okay, number 7, we got an odd power, we got a negative under the radical, so that's perfectly fine. So we know it's going to come out as a negative. And 12 divided by 3 is 4, so that's pretty easy. So it's negative b and to the 4th power. All right. If we just go down the line, we know this is a square because there's nothing right here. So the 16 comes out as 4. You got that little handy dandy cheat sheet. The a comes out as 5 or to the 5th power, and the b comes out to the 4th power. Make sense? All right. The 121 comes out as 11, and the x comes out as cubed. Okay, now a little bit of a curveball. So here you got 4k times 4k times 4k times 4k all under the radical. All right. So there's a couple ways you could, I mean, there's more than one way to kind of approach or think about this. All right. If we had 4k times 4k and then 4k times 4k, that's really what you have here, right? So it's to the 2nd power. So it's going to come out. I know a lot of you probably wrote 4k squared, right? But it really,
It's 16.
there you go. It's 16k squared is, and you may see this on SATs. They'll give you both these answers. All right. Whoever said 16, that is the more correct answer, the 16k squared. Does that make sense? All right. Again, don't let that plus or minus outside the radical throw your curveball. Just leave it be as is. Remember, we did the plus or minus when we were doing those perfect squares of solving quadratics. So it's kind of related to that. You've seen that before. The 169 is off your cheat sheet or off the top of your head for having done a lot of that. It comes out as 13, and the r comes out as r squared. That's actually to the 2nd power. All right. So now the negative is not influenced by the radical. We've got a negative under the radical in an odd power, so that is solvable, right? That is solvable. All right, so the cube root of negative 27 is a negative 3, so I got a negative times a negative 3. So now this becomes a positive, and 6 divided by 3 is 2. So these are pretty straightforward, and they're logical. Any comments on those? What, 6 there? Are we getting those answers? And if you're not, speak up, and I can walk you through, because there's a couple different ways you can kind of think about or approach these. Let's see if I get all 3 of those. There we go. All right. So the negative's not influenced by the radical. We got to take the square root of 625, which if you plug into your calculator is actually 25. Okay. And the y squared is y times y, so the square root of y times y is just y, right? Or 2 minus 1. All right, and we got z to the 4th is going to come out as z squared. The 36 comes out as 6. The q, let's see, that's q to the 34th is 34 divided by 2 is 17. Kind of an odd answer. All right, the 100 comes out as 10. The x squared comes out as x. The y comes out as y squared. And the z comes out as cubed. All right, we got a odd root and a negative answer, so that is doable. In the cube root of negative 0.027 is a negative, negative 0.3. All right. They threw you a curveball here, right? Because this is a square root. I got a negative under there. There's no 2 numbers I can square and give me a negative number. So this is a big no solution. Everybody get that one right? Yes. All right. 64, oh, it's 0.64. We're familiar with that term. That actually comes out as 0.8. And p to the 10th divided by 2 comes out as p to the 5th. All right, so now we got the fourth root of 2 to the x to the 8th power. So 8 divided by 4 is 2, so it comes out as 2x squared, which then becomes 4x squared. I said, if you see this on a standardized test, I can guarantee you they're going to have, this is going to be one of the answers. They're going to give you credit for that one. All right, so we got, this is a crazy one. So we got 11. Let's see, how do we want to approach this? We got 11 squared to the 4th power. There's a couple different ways we can look at that one. And this is a square root. Let's see here. Let's see. Simplify what's under the radical. So that now becomes, yeah, that now becomes 11. Yeah, okay. Here's one way. There's a couple ways you can look at this. So this now becomes, let's see. Let me think about this one. Oh, I got it. Okay. All right. That becomes, let's see. That's 11 to the 4th and y to the 8th. Let's do this. So there's a couple of ways, trying to think of which the least confusing. So if I got 11 to the 4th, let's do it that way. I think that's the easiest way to approach it. I don't have it under the radical. This is not the answer. This is under the radical. I just distributed, or I just kind of applied that 4th, right? So now we got, so the 11 to the 4th, pardon my messy writing, and 11 to the 4th, the square root of 11 to the 4th now comes out as 11 squared, which equals 121, right? So we're getting there just in a roundabout way. This was kind of a tricky one. All right, and y to the 8th, the square root of y to the 8th now simplifies to y to the 4th, because 8 divided by 2 is 4. So the final answer I'm looking for is 121 y to the 4th. That one's a pretty good curveball there. All right, any questions on that one? Everybody get that one right? That was a little bit of a brain teaser. Let's see, this one's kind of the same way. Let's see what we got here. So let's do it. I'm going to break it up into pieces. I'm going to apply that 6th power. So I got 5 cubed, or no, I got 5 to the 6th. This is all under the radical. Let me just do this under the cube root radical. All right, so I got 5 to the 6th. I got 8 to the 12th, right? And then I got b to the 6th. All right, and it's all under the cube root. So we watching? The cube root of 5 to the 6th, 6 divided by 3 is 2, so it's actually going to come out front of the radical as 5 squared, or as, which equals 25. 12 divided by 3 is 4, so I got 25a to the 4th. Sorry for my writing. And then I got b to the cube root of b to the 6th, so that's 6 divided by 3, and it's b squared. All right, that's those. Any questions? Are we getting those? Any Anything I can clear up, because we're gonna do something similar, but similar but different, which is, I know it's kind of a contradiction of terms, but along the same lines but different.
I have a question.
Sure.
How do you know if it's no solution or not?
Well, like in this one here, remember we talked about this last Wednesday. There, you can never, remember, you can never have something under the radical that's to an even root. 2, 4, 6, 8, 10, 12. Remember we spent 3 days or so on imaginary and complex numbers to solve negatives under the radical that technically weren't solvable. I kind of call it the smoke and mirrors of Algebra 2. You can have a negative under the radical as long as the root is an odd number. And let's use that negative 27. Let's say we're going to take the cube root of negative 27. So the cube root of 27 is 3, right? So if I took the cube root of negative 27, it's negative 3 times negative 3 times negative 3. Well, the first two negative 3's multiplied together is a positive 9 times that third negative 3 becomes negative 27. So the moral of the story is you're not going to be able to solve, and we're not going to use any imaginary complex numbers in this section. You cannot solve a negative under the radical when the root is an even power, 2, 4, 6, 8, 10, because it's not solvable. Make sense?
Yeah.
All right. Any other questions? All right. Let's see here. Let me see if I can still share without, oops. Give me this, let me see. Do all of you see problem set 2 now?
I don't.
You don't? All right, I'm gonna have to reload a share. Give me a second here. Where's my share? Okay. There we go. Yeah, since it's a different document, I gotta come out and then come back in. Okay. All right. The good news on this one, the bad news is the numbers are more complex. The good news is you're going to do all these. You are going to do all these with a calculator, right? No mental math here, all with a calculator. All right. Now, remember the stuff we did with the P's and the Q's and the I's and the W's and the irrational numbers and all that stuff back, what, before Christmas maybe, or right after Christmas? All right, so we're back to talking about irrational numbers again. And just as a reminder or a refresher, all right, so an irrational number is either does not terminate, or let's see, what's the best way to do it? I want to confuse you. An irrational number does not terminate, and it does not terminate. I guess it's about the easiest way to do it. All right. Irrational numbers go forever and ever. They could be, they don't terminate, and they could be a repeating number like this guy here is, for example. Or if you remember, another irrational number was pi, which was 3.15126, and I can't remember where it goes from there. All right, so we're going to most all of these, if not all of them, are going to be irrational numbers, and we're going to solve them using your calculator. All right. So we're just going to plug them into the calculator, taking the root of whatever it says in the corner of the radical. It doesn't say it's going to be a square root. So if you've got a TI-83 or an 84, right? I don't know if you can see me, but there is, if you don't know how to take roots other than square roots and cube roots, there is a, make sure I'm seeing it. If you look here, there is a math button right. I should stop sharing. Let me do this. Let's come out of here. All right, and let's see. All right, so you should, if you see, if you got a TI-83 or an 84, there is, let me turn the power on, would help. All right, so if you don't already, some of you probably already know this, just hit the math key, okay? And if you come down to, I'm trying to do this backwards, I think it's about number 5, there's a radical there. It's got an X in it, and you can toggle back and forth between the value under the radical, and you see that flashing, blinking light, the value of whatever root you're taking, 4th, 5th, 6th, 7th, 8th, 108th, all right? So that's how you're gonna do roots of stuff other than square roots and cube roots. If you look above this, let me back up here again. If you look here also under the math key and come down to, I think it's either number 3 or 4, there is a cube root function there. So you can just use that without having to type in the cube root of something. So it's a little bit quicker, but that one below it, or you can use any, any root under the radical. And then of course you've got the square root right down here where my finger is for doing square roots. All right, does that make sense? If you've got something other than a TI-83 or 84, you may have to just kind of, I don't mean to. Can you hear me all right? Yep, okay. I saw a red microphone there for a minute. You may have to, hopefully you've got a little manual, you can figure out how to do roots other than squares and cube roots. If not, my suggestion to you is just go to YouTube and say, how do I take, multiple roots on a TIX 170 or whatever model of calculator you have, and I'm sure there's somebody on there that'll walk you through there to do that. Okay. Questions or comments on that? All right. Let me see where I was. Let's see. I wanted to. All right. So here we're back. We're back here again. All right. So the big thing here, a couple things to hopefully make your life easier. Round to 3 decimal places, right? Everybody knows, let me just refresh our memories on proper rounding, okay? All right, so if we're gonna round to 3 decimal places, it's talking to the left of the decimal. So there's an answer rounded to 3 decimal places. It's 3 to the, it's talking to, I'm sorry, to the right of the decimal, all right? So if that, how to round properly is if that 4th number, whatever there was there after that 7, if that 4th number is 4 or less, 0, 1, 2, 3, 4, the 7 stays as a 7. If that 4th number is 5 through 9, that 7 now becomes an 8. And you've probably done rounding in Algebra 1, and you probably have done it in some of your science labs. Any questions, comments on that? So, like I said, my lesson on this is going to take all of 90 seconds. So you're going to do all this with your calculator. Let me just make sure on this problem set. Yeah, there's not a single variable anywhere on this problem set. All right. So for number 1, you're just going to plug 62 into a calculator. And if you haven't already done so, it's square root of 62. You know the square root of 64 is 8, so we know it's going to be a little less than 8, right? Just doing a little mental math. So it's going to be 7.874. I actually did this in my calculator. I did earlier. Let me come back. I can't recall. Let's see. It's this. Here. Why is that not working? The second key is not working. There we go. So the actual answer was 7.874007874. So it actually, this has repeating. So the number after that 4 was a 0, so the 4 stays as is. All right. And I'm going to do one more, and then I'm going to cut you loose because there's no point in me. Let's see. It just doesn't work.
Mr. Gaffney,
Yes, sir.
I found my quiz and problem set 3B.
Email.
And I emailed them both to you.
Okay. So if I
Alright.
plug in 1050 and take the square root of 1050, it actually comes out to 32.4. Let's talk, this is a good one to talk about. 3, 7. I'm going to go one more number. Okay. 3 decimal places. So your final answer is you're going to convert that 3 to a 4. And that's it. And so you got, there's a bunch of them, but it's all calculator driven. There's 18 of them. You got 2 of them done, so there's 16. It shouldn't take you 16 minutes to do them. And then you got 2 word problems there that you're going to take the, you are going to take the roots of, all right? So don't get kind of stressed out on, oh, this is a word problem. All you're going to do is you're given a problem there, plug in the values, and you're going to take, let's see, there's square roots on both of them, all right? So it's just a little practical application of doing these. And that's it. I could continue to do more, but you can type them into the calculator faster than I can. Pay attention to the small number. You know, if there's no number in the little v there, or the radical, it's always squared. If there is, then you're going to have to do. You got a cube root of number 3. You're taking the 4th root of number 4. The negative outside the radical just kind of rides along, stays as is. All right. I can tell you there is a solution for all of them. All of them are solvable. And that's all I've got, unless you've got any questions. And then we'll go over this on Wednesday, and then we're going to move on to 6-5 on Wednesday. I'll probably do a flexi quiz on this one with multiple choice answers, just because I'm overwhelmed with manually scoring quizzes and tests with 6 classes now. So I'll probably give you like a 12 or 15 question flexi quiz sometime after class on Wednesday for this problem set. I'm not going to, that first problem set had about 20 problems. Should probably be about 6 or 8 like that, and then there'll be 6 or 8 like these. If you want to look at, or let's see here, a couple minutes remaining. Let me clear the board here. Clear. All right. If you want to look at any of these that you may see a question to, if you haven't printed it out yet, and it's in Blackboard now, I'll be glad to answer. Otherwise, I'm going to cut you loose to do these on your own with the calculator.
So can we leave now?
I'm sorry?
So can we leave now?
Just a second. Any questions on anything? So finish this up for Wednesday. Those folks I mentioned earlier that I don't have a quiz from, make sure you submit your quiz today. I'm not going to, after today, I'm not going to go back and go on a search party to try to locate it. We just use their own, hopefully be the one that we drop for the quarter. Finish this up. We'll probably jump into 6-5, which deals more with roots and exponents on Wednesday after we go over this problem set. And I'll probably do a flexi quiz, multiple choice flexi quiz, because I found that flexi quiz, if you don't do multiple choice, it backfires on you. If I have time to get that set up for you sometime on Wednesday. Any questions on anything? Last call? All right, we'll take a couple minute early go. All right. I will see you on Wednesday. I still do office hours, 2 to 2:30 every day. So if you go to a snag or a problem and want something answered, jump on the office hours right after this. And that's all I've got, unless you got any questions. All right, everybody have a good couple days. If I don't see you before, I'll see you on Wednesday at 1 o'clock.
See you, sir.
Okay, take care.